right? When I go higher up into the air, temperature drops. If I am graphing the relationship, or if I'm discussing the relationship between temperature and altitude. I can also make the temperature drop by walking into a fridge, right? But my altitude didn't change. So obviously the altitude is the independent variable, right? Okay. I can identify if a relation is a function. One input equals one output. That's it. That's all a function is. So, 2, 7, 3, 5, 2, 8. Is that a function? No. Why not? When I input 2, I get 7 or 8. What about this? Is that a function? Yes, absolutely it is. Because 2 got me 7, 3 got me 7, 4 got me 7. No other number got it. My output on a graph would look like that. 2, 7, 3, 7, 4, 7. That's a function because every input gives me an output. No inputs are repeated. Determinative relation is linear. Up and over. Wait, I'm going to draw that smaller. On a graph, up and over, up and over. If these are the same, it's linear. Whether it's continuous or discrete, it doesn't matter. In a table of values, x1, x2, plus m, y1, y2, plus n. If those repeat, it's linear. Is this linear? Is that linear? Yes, of course it is. Because for every 1 I go up 2. So here I went up 3, so I went up 6. Discrete or continuous, and explain why. Yes. Discrete, we count. Continuous, we measure. Now, appearance is different. If I'm selling tickets to a Canucks game, even though no one wants to see them because they stink, 18,000 people fit in that arena. Do I make my graph with 18,000 dots? No. Can I buy half a ticket to a Canucks game? No. So the data is technically what? Discrete. How would it appear on a graph? Continuous. Why? The dots would have to be so close together. So you have to know the actual definition. Right? Domain and range. Domain is the set of inputs. It's the set. So in that example I just gave, the inputs are the tickets sold, which goes from 0 to 18,000. Is it every number from 0 to 18,000? No, it is only whole numbers, right? What's the relation? That's the set of outputs. A Canucks ticket costs $100. If there's 18,000 of them, that means I have sold $1.8 million in tickets. The inputs are 0, or the outputs are 0 if I sell no tickets, up to 1.8 million. Now, can I have an output of $150? No, because tickets are worth $100 each. So I cannot have an output of 150. But we would still graph it with a line. Everybody understand? All right. Possible situation for a graph. That means you can go graph to words. Tough to do an example of that, but speed, time. What did I do for this part? I increased my speed over a certain amount of time. What did I do here? Drove at the same speed. What did I do here? Slowed down. Done. I can sketch a graph from a scenario. I leave. I forget my wallet. I go to work. How would you graph it? Levi. What would you use? Okay, so what would it look like if we were doing displacement and time?
It would go up a little bit, and then it would go down because you went
Back to 0.
and then it would go up quite a bit.
Up quite a bit to work. Easy peasy. Right? Function notation algebraically and graphically. F of 2 looks like what? What would you write on the paper if I wanted the f of 2? You would write f of 2 equals 2 plus 2. What if I had the f of x equals 7? Now what does the paper look like? 7 equals x plus 2. If it's on a graph and I have f of 2, is that an x or a y value? X value. F of x equals 7. Is that an x or a y value? Y value. So on a graph, I would go to x2 and find the y. And on this one, I would go to y7 and find x. Everybody's good? Great. Class goes for a little bit longer. If I am unhappy with what appears to be the level of work being done, I 100% guarantee we're marking that review before the end of class. If you manage to fool me and you are actually using your time wisely and working and it seems like you need more time, we can mark that review Tuesday. Who will make that decision? No. Me. Based on what evidence? You. Go.